So as the title suggests, this video is going to be about doing a multiple regression, and it's going to be looking at data which has been collected for a sample of 1,000 pregnancies. So if you want to download the data, it's in this file here. So why we're going to look at multiple regression as opposed to a simple regression is basically we're going to have more than one independent variable with which we can make a prediction of our dependent variable. And what we're going to be looking at here is birth weight, alright, which is the first part of this question. So generating that regression model for birth weight, including, you can see here, we're going to use 6 independent variables. So let's do this as a first step. So jumping over to my Excel spreadsheet, this is what the data looks like. So we're going to try and predict birth weight, which is this final column, based on these 6 here, which are going to be our independent variables. So in order to do this, we're going to get Excel to do the bulk of the calculations, but what we need to make sure is that our data is basically in a numerical form that can then be included in our regression equation. So we can see that this column, and this one, they're all numerical. So they're all well and good to chuck in as they are. However, smoker and status here, you can see that these are in words. So they're like categorical variables. So what we need to do is change these over into numerical ones, and we do this using a dummy variable. So it basically just turns your categorical data into something that's numbers. So let's start by doing that for the smoker column here. So I'm going to insert a new column, and let's call it smoker, and I'm going to set 1 to be equal to yes. So basically that means then that 0 is our reference category corresponding to the no response. So coding this in, you can do this multiple different ways. I'm going to use an if command for it. So it's going to be if, and I'm going to select this cell here, and if it is equal to yes, so that's how I program that, the next thing I give it is what I want it to do if it's true. So if this is equal to yes, I want it to be a 1 that appears in this cell, and then the value of false. So if it's not yes, we want it to be 0. So what I can do is copy this down, and it should update the reference. So this second one here relates to this cell, and so on. And we can do that all the way to the end. I think if I double click here, it automatically copies that down. So looking at this, as a double check, we can see that this is yes and it's giving us a 1, and this is no and it's giving us a 0, and all the way down it seems to be doing that, so it looks like it's working. So that's completed there. So we can do the same kind of thing on status now. So again, for status, there's only 2 options. You're either indigenous or you're non-indigenous. So I will insert a new column to code that in. So this time let's go with 1 is if you answer indigenous, meaning that 0, our reference category, is when you're answering non-indigenous. So equals, again if I'm doing this with an if command, so I want this to equal indigenous. So if it equals indigenous, that's where we want it to be a 1, and if it's anything else, we want it to be a 0, and in our case the anything else is basically non-indigenous. So let's copy that down again, and let's have a quick check. So all of these are answering 0, which makes sense, and we can see we have an indigenous and it's answering 1, so that looks like it's all working well. Alright, so the next step is to try and do our regression using Excel. Now Excel is a little bit funny in that when we open up the dialog box in a moment, what we're going to need to do is select all of our independent variables. So it's going to be like gestation, smoker, and all of these and so on. And Excel is going to want us to have them all next to each other. So it's not going to like us selecting B, D, E, F, and H and I. We need to select everything in one kind of columns next to each other. So let's just make that happen. So if I cut this, and let's just put it on the end. And same thing for status here. So we don't want the categorical version, we've converted it into numerical. So let's just pop it on the end. Alright, so now they're all lined up, ready for us to input into Excel. So in order to perform our regression model, we go into the Data tab, and then we select this Data Analysis option. and it brings up a whole list of stuff for us to pick from, and we want regression. So hit OK. So the first thing it's asking for here is the y range. So y corresponds to your dependent variable, or the thing that you're trying to predict. So back in our question, what we were looking at was predicting birth weight based on these other independent variables. So birth weight here is dependent, so that's what needs to go in for y. So what I can do is select this one, and I'll scroll down to the bottom, and if I hold shift I should be able to select them all. So that's worked out okay. And now for the X range, this is all of our independent data. So we had 6 different values, or maybe I should say 6 different predictors, I guess, that we were considering. So we just need to select all of this data in column B through to G. So again, I'll pick the first one, and then if I hold shift, should be able to select all of that range. So that's looking good for us. So the next bit is we have a few different options that we can pick from. The only one that we need to tick is labels. This is because the first row of our data was labels or column headings. So that's just telling Excel to treat it as a heading rather than as data. And then down here, we need to give it an output range, so where Excel should spit its calculations out. So I'm just going to pick to spit it out over here from this cell. Everything else you can just leave, and if you hit OK, it will run you the analysis. Alrighty. Alright, so I might just make this a little bit bigger so we can actually read what we've got. So if we jump back over to our question, what we were asked to do was provide the regression model for birth weight. So I'm going to type this just underneath here in Excel. So our model is going to be, I'm going to write it as y equals, y being our dependent variable. It's going to be equal to B0, which is our just random constant or intercept that falls out, plus it's going to be the first coefficient multiplied by the first variable, plus the second coefficient multiplied by the second variable, and so on as required. So let's write out our one. So our dependent variable is going to be birth weight. That's what we're trying to predict. So it's going to be equal to the intercept, and the coefficient we got for that was about -1483. So next we add on the coefficient for our first variable, which is going to be gestation, and we can read it out here. It's about 9.67, and we multiply that by the variable itself. So that's going to be gestation. Alright, so now we go for the next one. So the coefficient here is, I can go back and just make this minus since it's negative. It's about 233, I'll round it to, multiplied by this one here, which is like your smoker status. Remembering that a 1 means that yes, you are a smoker, and 0 means no, you're not. Alright, next up we have the pregnancy weight. So this one's going to be plus. The coefficient is 1.89 multiplied by output pre-pregnancy weight, just to make it a little bit shorter. Alright, next we have plus 14.14 as our coefficient. This one gets multiplied by height. Plus, we have this one is your indigenous status. It's actually a negative value that you can see in here. So minus, it's about 180 times upright status. And then the last one is age, so plus 1.12 approximately, multiplied by age. So this here is the answer to the first part of the question, where it asks for the regression model based on all of those different independent variables. So I'll pop in here a little A, alright, for part A of our question. Alright, so the next question, if we jump back, part B is asking us to comment on the statistical significance for each independent variable. So what we had here was essentially a statistics test that was happening for the coefficients in our regression equation. So the null hypothesis for this, HO, it's going to be that our coefficient, which we were calling B, is equal to 0 in the first instance. Remember that the null hypothesis is kind of the boring one that suggests, just maintaining the status quo, no real change or anything like that. So what this B equals 0 infers is that there is no relationship between your dependent variable and your independent variable. So the alternative hypothesis is H1, and in our case, I'm going to treat it as B does not equal 0. Okay, so this is inferring that there is a relationship that exists. I'll just put exists, and that's between the dependent variable and the independent variable that you're looking at. Now, sometimes you'll be looking at testing this one way or the other, and what I mean by that is you might be looking for B is greater than 0 or B is less than 0. If you do either of these, then you're looking at a relationship in only one direction. So one being positively correlated with the other, or one being negatively correlated with the other. The reason I mention this is because if you do either of these cases, that corresponds to a one-tail test, whereas if you do B does not equal 0, that corresponds to a two-tail test. So you're checking both directions here. This one you're only checking one. So I'm going to treat it as the B does not equal 0, so we're looking for a relationship in both the positive correlation or negative correlation directions. So remember, whenever we do these hypothesis tests, we need to pick a level of significance, which is alpha, and I'm going to call it 5%. So what this means is that if our p-value that we calculate in a moment is less than alpha, our level of significance, then we're going to reject the null hypothesis. If the opposite happens, so our p-value is greater than alpha, we're going to say that there's not enough evidence to reject HO, so that means that we accept it. So in order to get our p-value, we're going to use Excel. So if I jump back over, so looking at our table that it's spat out, we can see that there's like a list of p-values here. And really the only ones I'm interested in are the ones that are associated with those independent variables. So I'm just going to highlight them. And this is going to be our answer to part B over here. So what it was asking us is whether we have a statistically significant result. So remember, if this p-value is less than our level of significance, so 0.05, then we're going to say it is statistically significant. Now, just a bit of a note again about Excel. So Excel performs the two-tail test. Okay, that's what I said that we were doing. But if you were looking at the one-tail test, then you would need to halve this value. Okay, so this is the two-tail value that Excel gives by default. So looking at this first one, here for gestation, so we've got a really, really small value here, right? It's 10 to the negative 12, so incredibly small. If you want to make it easier, I should mention, you can like format this to be, if we go to number and then decimal places, let's say we give it 3, it will round it for you, so you can see that it's incredibly small anyway. So since we've got a very, very small p-value here, that means that this is statistically significant. I'll put statistically sig. Okay, so gestation really does impact on birth weight. So the next one is your smoking status, and this one has again returned an incredibly small p-value. So that means that this one as well is going to be statistically significant. Alright, next we have the pre-pregnancy weight, and we can see that that is a number that's bigger than 0.05. So that means that we don't have enough evidence to reject our null hypothesis. So yeah, pre-pregnancy weight probably doesn't have a very big impact on birth weight. So I'll put not. Let's put stat sig so it fits. Alright, next up we have height. And we can see here that again it's an incredibly small value, so therefore it is going to be statistically significant. We reject our null hypothesis, accept our alternate instead. Alright, next we have the indigenous status. So this again is lower than 0.05, so therefore we do have evidence to reject our null hypothesis, making this one a statistically significant predictor. Alright, so the very last one is the age. and we can see that this is a number bigger than 0.05, so therefore this one is not statistically significant either. So that there is my answer to part B of this problem. So let's have a look now at part C. Okay, so here we're asked to interpret the regression coefficients for each statistically significant independent variable. So basically giving a comment around what this regression coefficient actually means in context. So jumping back to Excel, I'm just going to do it in here again. If I shift across, let's do it here in C. Ooh, defaulted to a, here we go, I'll put a space in there, defaulted to a copyright symbol. Alright, so this is where we're going to interpret. So we're only doing it for the statistically significant ones, so we'll start here with gestation days. So the coefficient that we're looking at is this 9.67. So what does that kind of tell you? Well, in terms of how it impacts birth weight, what we can see that is for every kind of day of gestation, since that's what it's measured in, it's going to add on 9.67 grams to the baby's predicted birth weight. So I would say here that birth weight increases by, we'll round it, 9.67 grams on average for each extra day of gestation. Okay, so that would be my answer there. Let's just hide these for now so that we can see the rest of that comment. There we go. Alright, so that's my answer to this one. So next up we have smoking status, and this one was statistically significant, so we do need to make a comment. So for the smoker, it was a negative coefficient, okay? And since 1 was equal to yes, this coefficient is only going to apply to people who are smoking. If you have a no smoker, then it doesn't matter what the coefficient is because it's going to be multiplied by 0, since 0 was equal to no. Okay, so in context, what this is telling us is that if you're a smoker, your birth weight is expected to be 232 grams less than if you're a non-smoker. Okay, so how we word that, I don't know, birth weight reduced by 232 grams on average for smokers. Cool. Alright, so this next one here was found to be not statistically significant, so it didn't really impact birth weight at all. So we're not going to make a comment there. The comment would basically be this is not a factor that needs to be considered in the equation. So next up we have statistically significant for height. Okay, so this one we have a positive coefficient, and we can see when that is applied to the equation here, it adds 14.14 grams for every, I think this is measured in centimeters, yep, so for every centimeter of height. So how we could comment on that, maybe birth weight increases by, what did we say, 14.14 grams. I should put on average for all of these, for each extra centimeter of height. Cool. Alright, next up we have the indigenous status, and what we can see here is we have a negative coefficient, and that applies when someone is indigenous. Remember again, our reference category is non-indigenous, so that's going to be equal to 0, so no matter what the coefficient is, it's going to get multiplied by 0 and not impact in our birth weight equation. So what that tells us is if you answer as being indigenous, you're going to end up with a negative, so less 180 grams for your birth weight. So let's pop that in. So reduced by 180 approximately grams on average for indigenous mothers. Cool. So the last one here is age, which we found to be not statistically significant, so we're not really going to make a comment on it, but if you were to, it would be that this doesn't really need to be considered in your regression equation because there's no evidence to support it being a significant factor. Alright, so that there is our answer to part C. Alright, so moving on to part D now. So here we need to look at making a correlation matrix for each of our variables: gestation, pre-pregnancy weight, height, age, and birth weight. Alright, so jumping back over here, We should be able to do this with Excel, but I think Excel is again a bit mean in terms of requiring you to have your variables that you want to consider all lined up. So let's just make that happen. So I'm going to remove smoker because that wasn't one of the things that we were asked to consider. So I'll just pop that on the end. And I don't think we were asked to consider Indigenous either, so I'll pop that on the end as well. So what we are considering in our correlation matrix is each of these columns here. So in order to create it, we go into data and then data analysis, and it's one of the options in here. Here we go, correlation. So hit OK. So our input range needs to be all the different values that we're considering. So it was these columns. So we can go through and select them all. So again, go down the bottom, and if I hold shift, I'll select the bottom right corner. So our data is sorted into columns, and our first row is labels, or those column titles as well. So we'll tick that box. So output range, we need to tell Excel where to put the spit out. So let's say we put it down here. Oh, I went over my input range. That's disappointing. Alright, so output is here. Let's go back and reselect the input. So it was from here all the way down to here. So hit OK, and it should have spat it out up the top where we asked it to. Oh, here we go. It's even selected for us. So this here is our correlation matrix. So I might just make these columns a little wider so we can actually read what's in them. Alright, so what we were asked to do in our question next was, after we created this correlation matrix, was to consider whether we thought multicollinearity was a problem for the regression model. So that's basically interpreting this matrix that we have produced. So this here is D. I'll pop that in. Alright, so part E is interpreting it. So we can see here that we have a whole bunch of numbers, and they should all be between -1 and +1. I'm going to go through and just round this again. Let's say we round it to 3 decimals, just to make it easier to see the numbers. So I'm just going to quickly recap over here what those correlation values actually mean. So it usually has the symbol R for correlation of a sample, and I'm going to put these bars around it. Those mean take the absolute value, or the positive value. So basically for this R value, if you end up with a value of 0, that could be interpreted as having like no relationship between those two variables that you're looking at. If you ended up with something as less than 0.3, that could be interpreted as weak. 0.3 to 0.7, this was a moderate relationship. If you had something greater than 0.7, it was a strong relationship. And if you have a value of 1, that means that it's perfect. Okay, so when you're assessing for this multicollinearity, basically you're assessing for whether a relationship exists between the different independent variables in your model. Okay, and multicollinearity will be a problem if you're scoring up in this upper range, okay, because those independent variables are then correlating against each other. So if we jump back over to Excel and have a look at our data, here we go. So we're going to discount all these ones which are 1, because that's height correlating with height, and pre-pregnancy weight correlating with pre-pregnancy weight. So it doesn't make any sense to look at those. But if we look at, say, pre-pregnancy weight against gestation, we can see we have a pretty low value here. And you keep looking here, height against gestation, again, it's pretty small. Let's see, the biggest one we've got is maybe this 0.266, which is still pretty low. Okay, that was in the weak range. So what this suggests for part E, where you need to comment on it, is that probably multicollinearity isn't a problem. Collinearity, however you spell it, is not really a problem here, okay, because all of our different correlation values are within the weak range, or even lower, almost 0 in some cases, like this one here. So that's it for that part of the question. So we're up to this very last bit where we need to interpret the regression coefficients to see whether they have the expected signs. So again, just a really quick recap on what we mean by expected signs. So if you have a positive regression coefficient, which is we're calling B, what you would expect is that you end up with a positive value for your correlation. Sorry, the word escapes me, which we were using as R. Okay. Similarly, if you have a negative value for B, you would expect a negative value for R. Okay. What this positive and negative value for R, or your correlation, means is that if you plot something against each other, so Y versus whatever X independent you have, if it's a positive relationship, then it should be trending upwards, okay? And this B value kind of corresponds to if you have an equation of a line, y equals mx plus c. It's like the m in this equation, or the gradient. So if this is a positive number, the line trends upward. So that's this case. The other case is kind of the opposite, okay? So if you plot x versus y, whatever your independent is versus your dependent, if you've got a negative b value, it should trend downwards like this, and you're going to end up with a negative gradient in this equation. So that would suggest that you have this negative correlation, where as one variable goes up or increases, the other one decreases. So that's what we're going to be looking for. So in our case, the y value, or y variable I should say, every single time is going to be our birth weight, and x is going to be dependent on which independent variable that we're looking at. So jumping across to Excel, so what we're looking at here is our spit out from the initial regression here. So we're looking at the signs of these in here. We're not really interested in this coefficient, so I'll drop that one. So we're looking at the signs here, and whether it essentially matches with the correlation values which are going to appear in this bottom spit out. Okay, because remember, we're looking at birth weight every single time as being our dependent variable, and then across the top here, these are each of our independent ones. Okay, so where they meet, that's the correlation between those two variables. So if we start with the first one here, which is gestation, we have a positive coefficient, and we can see we also have positive correlation. So this one here, the sign matches, so that's all good. So the next one we've got is pre-pregnancy weight. So if we go down here, pre-pregnancy weight, we've got a positive coefficient, and we can see that we have a positive correlation. So again, we've got a match in the sign. All right, next we have height. This one here is a positive coefficient. This one is a positive for the correlation. So again, we have a sign match, so that's all consistent. And the last one we've got here is age, and you can see here we've got a positive coefficient and a positive correlation as well. So again, the sign matches. Cool. So that's all there is for that part. So that's our answer in there to part F. So that's pretty much all there is in terms of this video. I hope that's clarified a little bit about how to perform a multiple regression and then interpret your outputs. And I'll see you in some of the other videos.